Hi, everyone. Hopefully everyone's been having a good Hashi days so far, and hopefully this is a really interesting session. This is a Learn Lab for building a GitOps pipeline to deploy a 3-tier application. And before I get into any introductions, any agendas, I wanted to bring up this slide. The hands-on portion of this lab is going to be ran at a speed that's designed to be followed along. So if you're someone who learns by just getting in there, hands on keyboard, we encourage you to grab your laptop, get situated, and also bring up this link on the side here. This is a written tutorial of everything we're going to be running today. So there's some links in there that are a little bit easier to just click than try to type out. Some things are easier to copy. If you're someone who learns better by watching first and then going through it at your own time, that link will stay up after Hashi Days. You can go visit it, run it, when you have some spare time. Either way, there's a few prerequisites for this lab. You'll need an AWS account with a key and secret. I'll give you a heads up, this does fall just outside of AWS's free tier. The kind of healthy estimate for this is something like $1 per hour to run it. I think AWS's calculator said it was more like 50 cents US per hour to run. But either way, just wanted to highlight that. You'll need a HashiCorp Cloud Platform account, just a free account. If you don't have one, you can go sign up for one. They toss a boatload of credits at you. It's great. You'll need a GitHub account. We're going to be creating a repository, making some changes. And you'll need an HCP Terraform account. Again, just a free tier account is fine. For that Terraform account, you also need to set up your GitHub account as a VCS connection. If you don't have that already, in that written tutorial, there's a link to the documentation to do it. Just a couple steps, takes a couple minutes. You can set that up while I'm going through some slides. So this link will be in the next few slides, so if you're still getting comfortable, no rush. But I want to introduce everyone who's involved in this lab today. So my name's Brian McLean. I'm a product education engineer at HashiCorp, which means our team spends a lot of time thinking about how you, the user, can learn and grow your skills with our tools. With me today are two of my wonderful coworkers. We have Usher and Mike. I don't know if you guys want to raise your hand or, so they'll be at the front here. They're serving two very important roles, both as your TAs today. When we have some time for questions, they're going to come around with a mic. And when we go into the lab itself, if you have some issues, if you get stuck, you can raise your hand and they can see if they can help you out. As far as the agenda today, I don't have too many slides to throw at you, but I did want to set some context. So I just want to put a definition to what I mean when I say GitOps. I want to talk about the benefits, the challenges, just give kind of a brief overview of who does it affect, and then we'll talk about the lab. We'll talk about what we're deploying, where we're deploying it, how we're deploying it. So I think that's enough preamble. We can jump right into it and answer the question, what is GitOps? Now, I could probably ask everyone in this room who may already have familiarity with this term to give their definition, and I'll probably get a different answer. My one and only hot take that I'm allowed to have is I think that's okay. I think what we've seen a lot in some of the previous talks today is we're sharing experiences, we're sharing opinions, and it's not really about what it looks like in your specific implementation, but rather what can help make your lives easier. So for me, just to put a definition to it for today, I'm using this definition, this formula for GitOps, where it's Git plus declarative configuration plus automation. So we'll work from the top. When I say Git, I'm just kind of using that as an umbrella term for any version source control. To be fair, Git is in the name, so we stuck with that. But the important thing here is that that code repository serves as your single source of truth for your environment. Right? That defines what you want out there running out in the wild, not the Git repository plus whatever tweaks you have to do to get it working. It's all in code. And you capture that in code by the declarative configuration. Spoilers for me, I'm talking about Terraform, I'm talking about Nomad job specs, probably not a surprise there. And then you need a way to put it all in motion, to build it, to test it, to deploy it, and that's where the automation comes in. This is probably where I see the widest gamut of technologies, GitHub Actions, Argo CD, Flux, whatever your tool of choice is. But what's really important is it doesn't matter if you're scaling out the servers, if you're changing the networking, if you're updating your application, the workflow to make those changes looks exactly the same. And that workflow probably looks pretty familiar. You can open up a pull request, you can do a code review, make sure everyone agrees, everyone's on board. You merge that pull request, and then that's where the automation kicks in to build it, to test it, to deploy it. So I want to spend a couple of minutes just talking about some of the benefits and some of the challenges. And we'll start with the good. So I just touched on it a little bit, but that consistent deployment model, that consistent workflow, I think is one of the biggest wins that you can get with this, right? Because when things are consistent, they're repeatable. And when they're repeatable, they're scalable. It's easier to troubleshoot. There's a footnote there. I'll clarify that. And it's easier to roll back changes. So if you made a commit, everything breaks, all the monitoring goes off, you get 30 pings on Slack and email, you have that Git commit history to say, oh, this is what changed. Why did we change this to a medium instance from an extra large? That's probably why things broke. And that gives you a place to look to troubleshoot. Now, I want to be earnest when I say that it becomes easier to troubleshoot, because there is potentially more to troubleshoot, right? You may know where to look, but now we're talking about implementing new technologies, new workflows. So there is a trade-off there. Collaboration is something that gets talked about a lot with GitOps, whether that's maybe a pie in the sky end goal of where your security team is opening up the PRs to patch those security vulnerabilities in their code, or what actually happens where you're just implementing code reviews and opening up issues. Just having that, again, single place to work together for that application from the infrastructure up. And then I use this word footholds a lot, but just having a way to express a voice into that deployment process. So if I'm the security team and I want to do things like code scanning, or I'm the platform team and I want to implement policy, knowing where all the definitions for everything lives, knowing where you can add those steps into that workflow is very, very powerful. Now, not just in tech, but in life, with everything, there are trade-offs. I didn't purposely put less words on this slide to make it seem like there weren't that many challenges, but I wanted to add some nuance to this, because I think the more appropriate title for this slide is questions. When we talk about complexity, we're talking about a learning curve, right? So we talked about those new technologies, those new workflows, and those new philosophies on how you operate day to day. That requires training. That requires everyone getting on board, learning how everything works, learning how these tools break so you know how to fix them. So I don't think it's an insurmountable complexity, but there is learning to be done there. Integration, I think, is a very, very interesting conversation. I'm not naive enough to think that every single person in this room is out there committing to a public GitHub repository, running GitHub actions, deploying to Kubernetes using Argo CD. I've worked at companies where when I started there, they were using source control solutions that were already a decade plus out of support. So I think one of the first things you want to think about is how can we integrate some of these philosophies, some of these workflows into the tools you have today? It's not realistic to just tear it all down and build it up. And then security. Not necessarily that it's insecure. I think anything can be insecure. But again, just those security questions that you have to ask yourself now. In this GitOps workflow, the point of integration into your higher level environments like staging, like production, is that pipeline. So what happens when the pipeline breaks? What happens when there's an emergency that needs fixed yesterday, not an hour from now when I can get those code changes in? Figuring out what are those break glass scenarios and having those contingencies to address them. So we've talked about the what's, and we've talked about the why. I want to talk a little bit about the who, not the band, but whoever is involved in some of these processes, who's really being affected by this. And I wanted to put a highlight on three different groups. At the front of my mind, maybe a little biased, is the platform operator. So these are the people who are primarily responsible for thinking about what's out there running, what are your servers, what does a Java application look like versus a Go application, and running and supporting that. And for them, I do think this is a really big win for enforcing those best practices. If you can do things like policy as code to kind of codify some of those best practices and make sure that they're being adopted throughout the organization, it makes it a lot easier to solve those problems when something does go out of those recommended patterns. And then just having that improved visibility. Whether it's just literally doing a code scan throughout these repositories to figure out what's being deployed, or maybe being a little bit more proactive and gathering metadata during that build process, just kind of having a handle on what's out there, what's running. The next group I want to talk about are the application developers. And for them, this is probably a familiar, if not an exact workflow they might be working with today. And where I think the win here is having that better, faster, more frequent feedback into their changes, right? So if we're making these changes that are going out of policy, that are breaking these best practices, I know the moment I open up that pull request, not on the day that we need to deploy to production. And then the third group, it does get mentioned in this conversation around GitOps a decent amount, but I do think it's something I want to stress more so than others, which is the security team, right? So those who are primarily thinking about how do we maintain a secure environment, how do we write secure code, how do we address security vulnerabilities, and for them, I think there's two big wins. Just like how the platform operator has that visibility into what's out there, so does the security team. And having that visibility means when there is a new vulnerability or something to patch or to mitigate, they know where to look to see, okay, it's these 30 servers affected by that. And then just enforcing that principle of least privilege, right? So I mentioned it before where in GitOps, the only point of integration into those higher level environments is usually that pipeline. So you're not giving out SSH keys or giving access to developers to SSH into machines to deploy things, which probably shouldn't be doing anyway, but nonetheless. And that brings me to my final point before we get into the lab, which is maybe the only point that if you've been kind of only half listening that I want you to walk away with paying attention to, which is what we're talking about today are principles and not prescriptions. I don't want you to think, hey, I can't implement all of this where, this is going to take years and years and years to implement. It's going to take so much time, so much work. What I want you to take are pieces, right? So whether it's a conceptual approach to a problem, whether it's a technological approach to a problem, whether you're a Terraform veteran of a decade or you're seeing your first line of HTML today, just thinking about how can we take a piece of this to improve our operations today. So I'll get off my soapbox there, and let's talk about the lab. We're going to be deploying a browser-based game. It's a 3-tier application. It's a really cool game. I don't think anyone's seen anything like it, and we call it Terraform. Very, very unique idea, I know. But jokes aside, what's important here is what's under the hood. So Terraform is a kind of standard structured 3-tier application. We have our front end. That's serving those web requests to the user, serving up the HTML, the JavaScript, the CSS. That communicates with a backend API that's handling information about things like high scores and player information. Both of those, in our case, are written in Go. And then that gets persisted to a Redis database. Now, what we're going to do is we're going to build a pipeline, keeping these 3 groups that we've highlighted before in mind, to build these 3 containers, to build a Nomad cluster that's networked by Consul, and then deploy it all into AWS. And what that looks like from a pipeline perspective is we're going to start with a GitHub repo. I might make a few people a little mad when I explain what's in this repo, because it's probably not how you should do it in production. But for the sake of the lab, we've put everything in one repo. That's the Packer template, the Terraform configuration, the application code, the build scripts, literally everything. I'll point out, GitOps does not mean a single repo, but in this case it is. Whenever we make a commit to this repository, it's going to kick off a GitHub action. We're going to look at what's changed. We need to figure out, okay, do we need to build the machine image that Nomad is installed on? Do we need to build those containers again? Or are we just changing the Terraform configuration? We don't need to actually rebuild the code. We're just adding more servers. Let's say we need to do all of that. So we'll build the machine image. This is what we'll install Nomad, install Consul, and give us an AMI that we'll deploy a little bit later. That's going to be done by running Packer in that GitHub, that GitHub action. And that's going to store information in HTTP Packer. We're then going to build our application container. Those are just a couple Docker files that we're going to do a literal Docker build on. And then we're going to kick off a Terraform deploy in HTTP Terraform. We're signaling this by creating a new tag on the repository. This is going to go out. It's going to communicate with HTTP Packer. It's going to communicate with GitHub to get those container images. And it's going to deploy it all into AWS. And then it's going to deploy our application on top of it. So that was kind of a quick rundown on what we're doing today. I'm going to say we have time for maybe one or two quick questions if anyone had any before we jump into the lab. I'll clarify, there's a spot in here that takes about 10 minutes to do a build too, so we're going to have plenty of time if we don't get to your question now. I can't see, so if... Cool. Oh. Oh, the first slide? Perfect. And I'll say that link has all these same prerequisites listed as well. So if you want to run through that, all the information should be there. Cool. Well, let's jump right in. I'm going to point out a couple of times where we are in this tutorial, but this is the exact same link that we had up there just a moment ago. And we're going to start by we're going to start by putting on our platform operator hat. So we need to give our application developers a place to deploy all their stuff. We need to give them the credentials they need. They need HTTP Packer. They need HTTP credentials, the AWS credentials. So we're going to set that all up. First, we need to give them access to HTTP. So I'm here on my project overview. I'm going to go into access control and click service principals. We'll create a new service principal. We'll call this GitOps lab. And we need to be able to write information into this project. So we're going to give this the contributor role. We'll click create. And then we need a key pair. Just like we have for AWS, we can create a key pair in HTTP. So we'll click on keys, generate key, and we have our ID and secret. I'm going to leave this window open because we're going to reference it a couple times a little bit later. The other thing we need to do is we need to make sure that our Packer registry is enabled. So back on my project overview, I'm going to choose Packer from the left navigation menu. Now, I've already enabled it in my project. If you're opening it now and you're seeing that you don't have a registry enabled, there should be a button that says Create Free Packer Registry. I think literally all you have to do is click that button and you'll see the same screen that I'm seeing. Cool. We're going to jump over to HTTP Terraform, and we're going to create that landing zone for the user, for the development team. So I'm going to click on New Project, and we'll name this GitOps. So this is going to serve as that place where the application team can deploy all the workspaces that they want. And they don't have to worry about managing that relationship between HTTP, between AWS. That's going to be handled by the operations team. And to do that, we're going to create a variable set. So on the left side, I've chosen variable sets and create project variable set. And we will name this AWS GitOps. We want this to be applied to every workspace in this project, so we'll say apply to the entire project. And then we're going to start adding some variables. And this is admittedly the somewhat tedious part. We kept this as simple as we could for this lab. I would say in a more production environment, you'd probably use something like Vault, and you can sync secrets to HTTP, to GitHub. But we're just going to start entering these one by one. So we'll start with our AWS credentials. All these variables I'm creating are environment variables. And I have a little helper script here, so I'm not leaking all my information. So I have my key. And we need our secret. AWS secrets, access, key. We're really testing my typing today. I'm going to mark this as sensitive because this is sensitive. And I'm going to copy that to my clipboard. This particular configuration takes in another variable to define the region that we want to deploy to. So we're going to call that AWS region. And we'll deploy to EU West 2. So that's everything on the AWS side. Now we need to give it information about HCP. So we have the information on how to communicate with HCP Packer. So there's 4 more variables we're going to need. We need the client ID. If anyone sees a typo, by the way, feel free to just shout out on my notoriously bad typing. We need the client secret. We'll mark that as sensitive as well. So we'll grab that from the key pair we generated earlier. And then we need to provide information about our HCP organization and project. So these are 2 more variables we provide as HCP project ID. There's actually a really handy way to get this. So if you're at your HCP project overview, you can scroll down to project settings, and it'll be in those that setting menu. So we'll copy that. And we need to tell it the organization ID, HCP ID. There's also another handy link that says, hey, are you looking for your organization ID? I am. Thank you very much. And we will copy that. OK, so that's all the variables we need to create. We're going to click Create Variable Set just to make sure that gets saved. Looking at my notes here. Great. So I'm going to take off my platform operator hat. I'm going to put on my application developer hat. I'm ready to deploy a new application. We have this great template that we can start with. It has all the application code, all the Terraform configuration that we need to deploy. So I'm going to use this template to create a new repository. I'm just going to toss that in my own GitHub account. And we'll call this Learn Lab GitOps. We'll mark it as public and create the repository. Now, I hope you had a lot of fun setting those variables the first time. We're going to do it one more time as fast as we can here. Before we do that, I want you to make sure actions are enabled. So I just jumped into my repository settings menu, clicked on Actions and General. And if you're seeing a screen like this, you're good to go. If you're not, you might be seeing a screen that says, hey, actions aren't enabled. Click this button to enable it. Again, I think it's just a single click to do it. And then since we are creating a tag or writing some changes to the repository as part of the action, I'm going to enable read and write permissions under workflow permissions. This is something specific to the lab today, not necessarily inherent to every workflow. All right, so I'm going to scroll down, go to Secrets and Variables, click on Actions, and New Repository Secrets. Key ID, pull up my little helper script. You might be thinking, AWS Secrets access key, how am I going to hide this since it's in plain text? I will script that part. That is the one thing I am scripting. Set the region, EU West 2 to match Terraform, HCP client's ID. Grab it one more time. HCP client's secrets. HCP organization ID. So like I mentioned, in a more production workflow, this is something you would definitely automate either through something like Terraform or use something like Vault. But we wanted to keep this with not too many moving parts for today. HTTP project ID. So that was updated a minute ago. I'm going to call one other little helper script. Okay, so that got updated. So all I did there was I used the GitHub CLI to set that secret value with my AWS secret. Okay, so we have our repository set up. We can create the workspace now in our project. So I'm back in HTTP Terraform. I'm looking at my GitOps project. I'm going to click New Workspace. I'm going to choose the version control workflow. And I have my GitHub account set up here as a VCS provider, so I'll choose that. And it should be the first repository here. And we're going to click on Advanced Options. So there's two things that we want to set here. In our case, for this scenario, we want Terraform to do an apply after every plan just automatically. We don't want to have to go through and explicitly apply it. But that is an option if that's how you want to configure your workflow. And then, as I mentioned, how we're signaling HTTP Terraform to do this new run is by creating a new tag on the repository. So I'm going to choose tag-based workflow. And then I'm going to click Create. Now, something I learned when I was putting this lab together is that HTTP Terraform doesn't actually do automatic plans and applies when you create new VCS tags, in this case, until you do one manually. This is actually a design decision, just so you're not accidentally doing applies right out the gate. So we're just going to do a plan-only run. That's actually going to fail. That's expected. OK, so we have our registry. We have our service principal. We have our project, our repository, and our workspace. That seems good to me. This is where I hold my breath, and we'll see what we break this time, right? So let's actually deploy this thing. I've gone back into my repository. I'm clicking on Actions. I'm choosing my build and tag action here. And we're just going to do a manual run just to get things initially deployed here. So under Run Workflow, I'll click Run Workflow. And we should see this kick off. And this is where we learn if we continue on with the lab or we do a live debugging session. So the first thing it's going to do is it's going to look at the files. This is actually doing a number of things. It's checking if certain files change to figure out what steps to kick off. It's looking if this was a manual run. If it's a manual run, just build everything. Yes, so you can see it's checking for Packer changes, application changes, Terraform changes, or if it's a manual run. In this case, it detected that this was a manual run. So we want to both build the AMI and the application container images. I'm going to leave this up. This is the part that takes quite a bit of time. So we'll look at some code. We'll look at those Packer templates, Terraform configuration. But I think this is a great time to also take some questions if anyone has any of what we looked at so far. Keeping it easy, I appreciate it. So let's just look at the code then. That sounds like fun. Open this up in a new tab. All right, so we have in our application directory is all our application code. We can see if we open that up, we're looking at the Go code, a few internal libraries, the Docker files for the back end and for the front end. These are what's actually being built right now in the action. We can see if we look at the back end here, I can expand this a little bit. We're based on the Go 1.22 container image. That'll be important in just a few moments. But we're not really doing anything special here. We're taking the code, we're building it, and telling it how to run it. On the Packer side, which is building the AMI right now, which is still working, so that's a good sign. We have a Packer template here, which is going through standing up a Ubuntu image. This one's based on 2204. And just running a few scripts, basically. I think it's actually this script right here, aptly named setup.sh. So what this is doing is literally installing Nomad, installing Consul, sending up the configuration so it knows how to talk to multiple instances of this image as it gets spun up. On the Terraform side, I think the two things that are interesting to look at, so we have the http.tf file. This is how we're talking to HTTP to figure out what we've just built. So we can see here, we're using the HTTP Packer version data source, and this is configured to reach out to our bucket, which is in HTTP Packer, and looking at something called a channel named production. Channels in HTTP Packer are kind of like tags for container images. I really like using them to promote images throughout a testing and production stage. So we can actually hop over and take a look to see how that looks in HTTP Packer. Here's our bucket, Nomad console. We can see that it's building one version right now. And right now we just have a channel called latest. Now, one of the steps of our action, not to look too far ahead, is that it's going to create a channel for this image. Yeah, create and set channel. So that's going to create the production channel if it doesn't exist, and then set it to point to this latest version that we've just built. What we do then is we use that HTTP Packer version data source in the HTTP Packer artifact. So this is saying, hey, I have a build which may have multiple artifacts. It could be multiple AWS AMIs. It could be in different regions. It could be multiple container images. But I'm saying I want the one that's for AWS in my region, in this case, EU West 2. Where we use that then is to stand up Nomad and Consul. So this control plane file is standing up the server instances for Nomad. Nomad has basically two classes of nodes, a server for kind of that control plane, interacting with the API, scheduling everything, and then the client, which is actually running the workloads. And if we look at the AMI configuration here, we can see this is where we're referring to that data source. So this is kind of what's connecting everything together from building the AMI, storing that metadata in HTTP Packer, pulling it down in HTTP Terraform. Everything else is pretty unexciting networking stuff, VPCs, subnets, all that fun stuff. And I'm going to bring up to see where we're at here. OK, so it's finishing up creating the AMI now. What's going to happen after this is it will create that channel like I mentioned. And then it's going to take the last step in this job, which I can go over and show the action definition of. And it's going to create a tag. So the script that's going to call is going to take a look to see what tags we already have on the repository, bump it up by one minor version, and then apply it to the repository. So that's what's signaling HTTP Terraform to start that run. I'll bring back up the action that's being ran, because we actually ran through that pretty fast. And I'll just throw it out there again. If there's any questions, any thing that could be clarified, this is a wonderful time for it, because all we're doing is looking at a build now. We can keep digging into code, too. That's always fun for me, too. OK. Feel free to interrupt me, because I think at this point I'm just vamping. So let's see. Let's take a look at what will end up in HTTP Terraform. I think that'll be interesting. So as I mentioned, it is pushing up information about the AMI, but we're also pushing up metadata about the build that triggered this as well. It's going to capture things like the Git commit. It's going to capture things like the GitHub action runner. So we can link this back to see what changes caused this build to be ran. Similarly, on the HTTP Terraform side, we're going to see that it's going to point to that commit, point to that Git information, linking this all together so we have this kind of history of what's caused this change. This was my plan from earlier. That errored. That's totally fine. Perfect. One other thing I'll point out, just since we have the time to talk about it a little bit, there is one other component that's going to be deployed to Nomad, just so that's not a surprise then. We're going to be deploying a reverse proxy onto every client node. So what this means is our networking will go from an AWS load balancer into that reverse proxy. That reverse proxy will use Consul's networking to look up where it's a specific instance of that application is running, and then forward the request there. So we can take a look at that definition here. We see we're running just the Nginx image, and we are quite literally just putting in a Nginx configuration into it. On our application side, we're defining 3 groups in our job. We have our Redis instance here. That is using the Redis Alpine image here. We have our backend. So this is running that Go application, which is serving up those those backend requests, communicating with Redis. And then we have our front end. So this is serving up those web requests. We're actually doing something we're in our Terraform code, we're actually replacing this image name with the specific build ID that we're getting from GitHub. So I just want to point that out because that is not normal in Nomad jobs, but more specific to our lab today. So this should be wrapping up in just a moment. Here we can see this is where we're doing that replacing of the templating as well. So just kind of more complete look into exactly what's happening when we deployed this Terraform configuration. All right, we have movement finally. So it's finished creating the AMI. It's shutting down the instance. This should be wrapping up in just a moment. So it's created that channel like we've talked about. And it's kicked off that action to create the tag. So once this starts, we're going to see that it's going to create a tag 1.0.0. And now that that's finished, if we go into HTTP Terraform, we can see it started a new run automatically. So this is continuing that automation that we talked about, where once we make a change, it's fully hands-off from the moment that we go from code to running. If we take a look at the run details, we can see here's the commit that triggered it. Here's a tag that triggered it, the repository that it's from. So we have a lot of this information that we can use to refer back to what caused this change. We can see there's a number of things that are being created here, 63 things, everything from the Elastic IP, the load balancer. We can see that we're creating 2 AWS instances called public client. This is what's going to be running the workloads on Nomad, and 2 server instances. So this is what's going to be doing the orchestration. So we'll let this run. And I can get the next part of the lab ready to go as well. Great. So we can see it's already starting to spin up all the infrastructure. It's going to stand up all the VPC, all the networking that we need, start standing up the servers. And then we can actually start seeing this running instead of waiting for circles to turn into green checked boxes. Perfect. So while that's finishing running, I'll start talking about the next part of the lab so we can not sit here in silence awkwardly. So I'm still thinking as an application developer now, right? So we have our initial deployment. We're going to have our application running, and I need to make a change, right? How we have this configured now is every time we make a change, if I look at this workflow again, we have a couple helpers here. So if we only change our application, we're only building the application. We're not rebuilding that AMI. We don't have to sit through this, 10 to 12-minute deployment process just to change the background color from gray to a slightly different shade of gray. If we're only changing the Terraform configuration, we don't need to build any of this, right? We're just scaling our instances. Where I want to talk about is if we're not the application developer, if I'm the security team, right? I'm doing an audit of all the applications that we have running in our infrastructure, and I've decided, hey, Go.1.22, that's too old for us. We don't want to support that anymore. So we are putting out a new best practice to say, hey, we're only supporting Go 1.24 and up. There's a couple ways you could do that. If you're like some of the organizations I've worked at in the past, early in my career, it's you send a bunch of emails until you find the right person to do it. But now we know where this configuration lives, right? If this is in the application repository, it's also with the infrastructure configuration. In fact, if we look at this dockerfile.backend, again, that's where we're defining this. So I can open up a pull request. I can open up an issue to change it. Or I can add to this pipeline as part of the test to say, hey, we've done a code scan on your application. We don't support this anymore, or we're not going to support it in the future. Please start testing those changes so that we can deploy them. Just keeping an eye on this run, just waiting for the server instances. Similarly, from the infrastructure side, so I want to lay out another scenario where if I'm the application team, I want to add some new functionality to this app, right? It's very resource intensive. It's using whatever the cool new technology is, but it's going to triple the amount of CPU and quadruple the amount of RAM that we have. Well, if I'm having that conversation with the platform team, usually how that would go is, I don't think we have enough resources for that. Figure that out on your own. But again, if we look at the same repository, we can update this in code by just scaling our client count. So this is something you're probably doing today if you're a Terraform user. But again, just having that collaboration and being able to enforce this kind of and give voices to the teams across your organization into that deployment pipeline, I think is a very, very powerful pattern. All right, we're starting to see servers finally come up here. So we have our first server up. The second server is coming up, just finished. And once this completes, we should just be waiting on our clients. So what's happening now, just to kind of give a view into everything that's going on, we have our Nomad cluster just coming up. The last thing it's going to do, it may have actually already started that as well, is it's going to deploy our Nomad application, good timing, right there with it. So the single Terraform configuration is handling everything from 0 all the way to our running application. That was very weird. It said apply finish, and it was creating 6 more resources. OK, so our apply is done. We can actually look at something. I'm going to open up the app URL here. So we have a few outputs here. We have our app URL. This is our running application. We have our Nomad UI. We have our Consul UI if we need to access those. And then we have our Nomad token. So this is how you'll authenticate to Nomad. I've left this as a non-sensitive value for the purposes of this lab. You would definitely want to mark that as sensitive in production. We might still get an error on this. That's expected. Yes. So what's happening now, we can show that Nomad is currently spinning up our application. I'll hop over there, log into Nomad, and look at our jobs. So we have, nope, No, thank you, 1Password. I don't want to say that. We have our Terraform job, which is currently deploying our application. We can see it's already brought up Redis. It's working on the back end, and it will deploy our front end. So once this is all up and running, we should, fingers crossed, see our running application. We are back-end up, and we should see our front end come up right after that. It's pulling down that image, starting the task. Give it just one more moment as it's spinning up. By the way, we can see our proxy is also running. This is that reverse proxy that's routing that those requests. And we have a running application. So I'm not going to make you sit here and watch me play Terraform. But we can see that we have up here, we have our high score. If we refresh, that's getting persisted. So that's being done by sending that request to the backend, storing that in Redis. So these next parts will go a little bit quicker, I promise. We want to go through those two scenarios that I just laid out, where we're the security team, we want to bump the Go version. We're the infrastructure team, we want to scale our infrastructure. So we'll go back to our code. And I'm going to open up in the app directory the dockerfile.backend file. And in our case, we know this works. We'll commit these changes. We'll create a pull request. Normally, we would have, tests, but I didn't want to make you all sit through all of that as well. So I'll create my pull request, and it will say, looks great, let's do it. We'll merge it. And while that's running, I want to show how we can verify this. So up here, I have this little debug menu. It's very handy, and we can see that we're actually running currently Go 1.22. What's happening now, if I go back to my code, if I don't lose the tab, so we kicked off this action again. And thankfully, I'm sure you'll all be thankful, we see that it skipped the build AMI. It's going straight to just building the container image because that's all that's changed. So this will be pretty quick. But again, this doesn't necessarily have to be just updating the Go version. This is any application change, right? If I change the CSS, if I change any of the HTML, this is exactly how it would run as well. So it's running Go build to build our app. And then it's going to push those changes up as GitHub packages. Looks like the build succeeded, pushing up the layers. And saving those as packages. So just like we saw before, it's going to go and then create a tag to tell HTTP Terraform, hey, we need to do a new build. And if we flip over there, we look at our runs, we see that it's starting a new run for tag 1.1. We're going to let this plan run out, but what we're going to see is it's going to be updating the images that it points to. It's going to deploy it. We're going to see that roll out in Nomad, and then we should see this running as our application. Again, we probably have time for one or two questions at this point. If anyone just wants to talk too, that's great. So we should see this plan finish. Not a lot's changed here. So we see it was just our Nomad job spec that's changed. And specifically, it's updating the two images. It's updating the backend image here and the front end image. That looks great to us. It's going to go through and deploy that. And I'm just going to bring up Nomad here, because what we should see is that it's going to start rolling this out again. Again, for the purposes of this lab, so we're not deploying like 30 servers. We only have one instance of this application running, so it's actually going to go down and then come back up. Nomad does support rolling updates. I think actually by a few different methods, which is pretty cool. But I did want to call that out in case we do see that 503 error again. So it's already spun, it's kept our Redis instance, so that's the same. Yeah, 66B16. Yeah, so it's kept the Redis instance. We're persisting all that data. It should be spinning up our backend and then soon after our front end. You might actually see the front end fail once, and that's totally fine. Again, you can set those dependencies in Nomad to actually spin up one after the other. Great, so this is running. If we refresh, we'll see if we do get that 503 or not. We do not. And we're on 1.24. So maybe not the most technical, involved change, but kind of demonstrating that principle of, hey, we did this in code, it's tracked in code, we have that git commit history to show what changed it, and we automatically applied that into our environment. If we look at it from the platform operator side, I'm going to go ahead and start the change while we wait for that and then talk about what's going on. So we talked about how we want to scale out the number of instances in our Nomad cluster so that we can deploy bigger apps, more instances of the app so it doesn't go down when we deploy a new version. So how I'm going to do that is I'm going to hop in my variables file, and we're going to bump the client count from 2 to 3. We'll propose that PR again. Looks great. We'll merge it. And it's going to kick off that exact same workflow one more time. What we're going to see from here is it's going to skip both the AMI and the Terraform application image build because, hey, all we did was just update a variables file for Terraform. We don't need to rebuild our application. So it's going to go straight to creating that tag. We can see it created the tag 1.2. And in Terraform, we'll see one more run to match that tag. So this is going to go and create a new instance. It's going to update a couple things that kind of just by dependency relationship does get updated as well. But on the Nomad side, what we're going to see is that currently we have our 2 clients. And what drove this decision, by the way, is taking a look at what resources are being used today. So if I go into my topology tab on Nomad, we can see, yeah, we're looking pretty healthy now, but this is one instance of our application. If we wanted 2 or 5 or 10, we have nowhere near the amount of space for that. So again, as your application teams are talking to your infrastructure teams, this is something that can be planned out, can be captured in code, can be collaborated on. Even if you want to inverse that workflow where the application team proposes this change and the infrastructure team reviews it, I've seen that work as well. And if we look at Terraform, we'll see what's going on here. So like I mentioned, we're creating one new AWS instance. A couple of these just kind of get updated by way of adding an instance to the load balancer. We create a couple tokens for it to register with the Nomad cluster. It's going through and creating that now. Actually, that was, for once, faster than I expected. So if I hop back over to Nomad, look at our clients, what we'll see here in just a moment is we'll see one more client join the cluster. Takes just a moment or so for it to finish spinning up to join the cluster. And we see that we have client 0, client 1, and client 2. So I know we looked at some kind of basic examples today, updating the version of Go, scaling the number of instances. But again, what I really hope that you got out of this today was not the exact implementation, but again, those pieces, right? So either if it's the concepts that we've talked about, whether it's maybe one of the pieces of technology, I'll admit, I had actually never used Nomad before working on this lab. Turns out it's pretty cool. So I know I'm going to be spending some more time with that. But just finding those pieces that you can take back, think about how you can incrementally improve your operations today. Now, I did not use anywhere close to all of my time. We have time for questions. Again, I'll throw it out there one more time. If not, I'll be at the after event. Feel free to come up. We can chat. You can yell at me for my definition of GitOps or my code, but I'm happy to talk. Not seeing any question?
First of all, I'd like to thank my parents for getting me here today. Sorry about that. Just a question on Nomad.
Yeah.
So it's managing container images on your AWS virtual machine. Is it something? And you mentioned clusters, so I'm familiar with Kubernetes, but is it akin to that, or?
Yeah, so what it's doing on the back end, and Mike and Ash, you can keep me honest on this since I am kind of a Nomad newbie, but it is a container orchestrator. So in this case, we're running container workloads. One of the cool things I think about Nomad too is it's not just containers. It can also instrument, I think, like JVM workflows, for example. But yeah, for our use case today, it's doing something very similar that Kubernetes does, where it's figuring out where to place those containers, where to run them, doing the health checks, making sure they're running fine. Cool. Any other questions? No? All right. Well, thank you, everyone. Hopefully this was useful, and I'll see you in a little bit.